All right, lesson 5, building quadratic functions to describe situations, part 1 out of 3 parts, actually. In this lesson, we explored the distance traveled by a falling object and the distance that it falls in a given amount of time is an example of a quadratic function. Galileo discovered this. Apparently, he dropped cannonballs of different masses from the Leaning Tower of Pisa, which is about 190 feet tall, to show that they travel the same distance in the same time. In fact, this equation right here tells us how far an object that is dropped will travel in t seconds. 16 times whatever the time is squared. Time times time. No matter what its mass, that's always what it's going to be. Now, that's ignoring air resistance and things like that. If you drop a feather, it's not going to fall at the same speed because there's other forces acting on it. But generally speaking, falling objects fall a distance of 16t squared for the amount of time. If you take a look here, these are the distances that a cannonball would fall for 0, 1, 2, and 3 seconds. Now, the reason why 4 seconds isn't included on here is because the tower is only 190 feet tall, and if you put in 4 seconds, 16 times 4 squared, you get 256. It hits the ground before 4 seconds. Now, the distance that the cannonball falls increases each second. And actually, in class yesterday, one student even said that the ball is accelerating as it falls, which is, it's getting faster. So as it gets faster, each additional second, it will travel further and further. And you can see that in this table here. As the change from 1 second to the next, this increase right here gets bigger with each second. Now, this is for the distance that it's fallen. Sometimes what we would rather do is come up with an equation that tells the distance from the ground. That's a slightly different calculation. So if you take a look at this, here's a table of values that shows the distance from the ground in feet after a certain number of seconds. Well, if you go back, this tower we said was 190 feet tall. So at 0 seconds, it would make sense that it's 190 feet off the ground. And if the distance traveled is 16 times t squared, after 1 second, well, distance 16, 1 squared, 1 times 1 is 1, 16 times 1 is 16. So the distance it's traveled is 16 feet. So if it started at 190, and it fell 16 feet, that's where we get this 174. So this is equal to 190 minus 16 times 1 squared. This would be 190 minus 16 times 2 squared. This would be 190 minus 16 times 3 squared. And if we want to figure this out for t seconds, that would equal 190, well, the height of the height from the ground would be 190 minus 16 times, well, not 1 second, not 2 seconds, not 3 seconds, t seconds. That's where this equation here comes from. The height from the ground is going to be the height that it starts from, minus whatever distance it's already traveled, which we already know is 16t squared. So, taking a look at the cooldown, the expression 16t squared represents the distance in feet an object falls after t seconds. The object is dropped from a height of 906 feet. What is the height in feet of the object 2 seconds after it's dropped? Find the distance that it traveled, take that away from the height that it started at. Write an expression representing the height of the object in feet, t seconds after it's dropped. If only I had an example of that in my notes. Let me know if you have any questions.